So it's we are recording, and I would just like to go through some things that we discussed earlier that would assist. So first of all, I would like to talk about the hypothesis testing and the ways we select our hypothesis. First of all, we'll start by saying there are steps in hypothesis testing. The first one is to state your hypothesis, and this is done by understanding the knowledge behind the test you're supposed to carry out. Let's just take here and let's take with the one way. Now, we want to confirm if these treatment outcomes have an effect on probably the time it takes for these people or patients to recover. Now, that has informed your hypothesis, you understand? So, like I said before, too, that in healthcare, it is always advisable to use a hypothesis that is less than a p-value that is less than, and a confidence level that is less than 9%, because of health is a critical aspect of life, and um, giving too much chance to error is really something you should be very careful about. So that being said, we can now say this treatment, since we are talking about one-way ANOVA, we'll say these three treatments as a whole, we are not now looking at them differently. That's what one-way ANOVA does. Are there changes? Is there a significant difference in the recovery time of this patient by this when they collect these three treatments? If it is significant, then we can now go further to want to know which of these treatments are kind of like different or have more effect or have greater effect. Then we can now put in other tests. That's what analysis of variance does. It checks the variables within a particular uh, uh, constraints, like your factors, the treatment A, B, C. Since it's a one-way ANOVA, this is what it will do for you for now. So we'll still go forward and talk about other things. If you have questions, don't forget to ask. So the next thing is to set our hypothesis level. Don't forget that in stating your hypothesis, you always try to negate your null hypothesis. You try to negate your null hypothesis by using terms like no significant difference or it's not, you understand? So in this case, we say treatment A, B, C does not or has no significant difference with the time for recovery of these patients. That's how we state our null hypothesis. Then at that point, we would also now have to also state our alternate hypothesis, and we'll say treatment ABC has a significant difference. At this point, you're not negating it again. It has a significant difference in the recovery time on the patient. So now you set your alpha level. There are so many factors that affect your alpha level, like the chosen field you're working on, the degree or level of errors you don't want to leave out for. Like I said, in the health sector, more especially in the health sector, I used to mention this because when we carry out health analytics, especially when you're trying to prove drugs or vaccines and the rest, you need to be critically very, very careful. It helps a lot. So in the health sector, your p-value should be less than 0.01, which is, yes, which is 99%. You understand? It should be less than 99%. That means you're giving Okay, so hold on, let me explain that confidence level for you. Your confidence level is just like in your number line you have from 0 to 100. So when you say I am 95% confident, it means that you're giving 5% to chance in this your analysis you're carrying out. Do you get what that means? It means you're giving 5% to chance. That means you're now looking at that 5% chance. At that 5% chance, once you carry out your test and your p-value is less than that 5%, which you have given to error, you understand? Which you have given to error, you can now say, if it is less than, you say it is significant enough for you to talk about. But if it is not significant, you now see you now try to do more tests to see why it is not significant, or even when it is significant, it also might require more tests. You understand? So in statistics, just like in analytics, you still plan to collect analysis, collect data, you determine your T statistics, either you use your T test or your Z score. Mostly these are when you're kind of like working with by hand, not like when you're using your system. Because when you're using your like let's say even if you are using Excel brings out the Z test and also brings out your T test, and sometimes all or any other test that is required in your analysis, but you always find the p-value there. So most of the times we don't look at the p-value once we are using softwares to analyze data. What we concentrate, we don't look at the t-test, sorry, and z-test sometimes when we are using softwares to analyze data. What we will concentrate on is on using our p-value, which is also a result like that has been confirmed by the Z and T test. The T test, you need to use a table. The Z test, the Z score, you need to also use a table to check all that too. So it is advisable to just use the P value since you're using a software for analysis. So don't forget, you need to now collect data. Certain times you need to collect data after you have been informed of the kind of analysis you're doing, because if you collect data before you start analysis, you would work towards the data. But if you start an analysis and collect data, you'll be working based on your research, and it will guide you to analyze what you had in mind and not what the data wants you to analyze. So certain times you find people analyzing what the data wants you to analyze. You understand? So you should check that as well. So we should determine our p-value. You understand the extremes. We should determine our p-value. Then once we've analyzed our data, we now make our decisions based on if our p-value is less than or equal to our alpha level, which is our confidence level, we should reject the null hypothesis. Then if our p-value is greater than our alpha level, we should accept or reject the we fail to reject the null hypothesis. As I told you before, we don't claim to accept the null hypothesis, so we fail to reject the null hypothesis. That's that. So let me just put out some of these things we said here so that it will be in the recording. Oh, I copied it wrong. Copied it wrongly. Not a problem. So let's continue. Now let's. Do you have analysis on your Excel? Do you have this? You don't have it. I know you don't have it. So let's go. Let me show you where you go and get it. Go to File. Go to Options. Go to Add-ins. Inside this Excel add-ins, you click on Go. I usually where did you stop? Yes, just click on Go. Yes. Pick if you have VBA to pick. If you need these two, you pick. But for now, these are just the ones I need. Just take Analysis 2 part for now. Leave that of the VBA. And just OK. Once you OK it, you come to data, you see a new tab under your ribbon. Yes. You've seen it. Good. So what you just need to do is click on data analysis. What we are working towards, there are other analytical or statistic you can check here. The two-way correlation. You can also check regression. There's regression here. Yes, regression, t-test. Yes, you can just try them out. You can just try them out. Yes, so we are interested in the single factor ANOVA. Click on OK. You shift this. You highlight. Yes, I can hear you. I think no, it's for different problem. They have their separate use case. Yes, it's for different. Let's do that of the one way. I will explain with the one way for you now. How many factors do you see here? What happens is one way, how many factors are you looking at? You're technically looking at two factors, but in this case, in a one-way dimension. Because the only factor that you have on your screen here that you're very visible about is your treatments as one factor. Even if I put treatment D now and I use all of them, you understand, together, I am combining all of them together, you understand, so that I can find out what they do. You might be looking at multiple factors, but you're looking at them in one way. You just want to get a summary of their effect. I'm trying to explain this in the easiest and plain way for you. You understand? You understand? Do you get what I'm trying to say? Yes, you're looking at these factors now. There are three treatment factors, but you're looking at them in one way. You understand? In one way. So what does that tell you? You have multiple treatments, but you're looking at them in a single factor to check if they have effect or not. If tomorrow you have multiple treatments and you want to look at them differently, you can now say, oh, I want to look at these treatments in a different light. You understand? But now we are looking at them in one way. That means we just need one summary answer. Are they effective or not effective? So you said it's cheap as how? It's easier. Yes, in a single way. Yes, that's just what you can say. So this is alpha of, we have chosen our alpha, that is our confidence level, to be uh less than this thing, it should be one. Yes, 0.01. You understand? So we want it in a new worksheet. You can still select an output range here if you want the output to be here in a new workbook, but let's just keep it in a new worksheet. It's easier that way. So in a new worksheet, it comes out like this. So once it comes out, this value here, you know what this value is? I know it's a little bit confusing sometimes. This value is 0. Yeah, this is 0.16 zeros. Then you have 416. You understand? So uh, what it means is that it's actually highly significant, if that's any way people can say it. You understand? It is very significant because in this case our alpha is our confidence level. Our P is less than our confidence level. And if you remember, what did we say at that point? We reject the words, the null, to be very specific, null hypothesis, null. Yes, the null hypothesis. So when you say reject the null hypothesis, what does it mean? It means that this test is highly significant, that these three treatments, you remember, yes, has effect on the treatment, on the time of recovery, you understand, of these patients. What it now informs somebody is that I need to go further to check which of these treatments has more effect than which other one. Then you can now apply another type of statistic to get your answer. Is it clear? Yeah. Null hypothesis. Okay. Yeah, you can write it down so you don't forget. Another thing, let's move to the two-way ANOVA with, without replication. Now, in two-way ANOVA, you could notice something, that you have two factors, two different factors, which are day and word. Here, you need to know what a column is. A column is your day. Then the words are your rows, because it will help you later on when your results are out. Now, what does it mean? On Monday, you understand, they kind of like applied, let's say they did surgeries, they did surgical stuff, 7 point something. Um, this data, let me check this data again, please, because I've forgotten uh, what the data actually talks about. Oh, okay, satisfactory level. Sorry, it's on satisfactory level by word and day. So on Monday, this is the satisfactory level of people that did that performed the activities in the surgical ward. This is the satisfactory level of people that did something in the medical ward on Monday. So you see now, there are two factors you're looking at. Although if you look at it better, there are three factors. But what you're interested in is the two independent variables. as your factors. I didn't mention it in the one-way ANOVA because I was trying to break it down. In the one-way ANOVA, the factors you saw here, these treatments are your independent variable. The factor that is inside or inherent in these values, which are the time for recovery, was your dependent variable. You understand? So what you're interested in is your independent variable. If you look here, we are only interested in our independent variable, while our dependent variable, which is the satisfactory level, and are these scores. Now, why is it without replication? Why is it without replication? It is without replication because each surgical and day value, each word and day value has one single value attached to it. If there was multiple values attached to a Monday and a surgical value in that it repeats itself, you can now say it is repetitive, you understand, or with repetition. But for now, we have one single value without repetition. So just have it at the back of your mind that that's it. You follow the same process like we did for the one-way ANOVA. This time, you choose without replication, you select your data, you make sure to pronounce that you have labels on your information, and okay, as simple as that. Now, I told you earlier to remember what rows and columns stand for. What were our rows? Our rows were words, and our columns were days. Don't forget that our what they call it, our satisfactory level was what I said was our dependent variable. We missed out on something. What was our null hypothesis here? Can you try to give us what our null hypothesis is? At this point, we have two null hypotheses. One for rows, which is word, one for columns, which are days. Which one are we rejecting? We have two p-values here. So, okay, hold on. I want you now to say it like a statistician. State your null hypothesis. State your null hypothesis for word. There is no difference, there is no significant difference between the satisfactory levels of patients in words. You can put it that way. No significant difference between the satisfactory level of patients in words. Then there's no, the next one is there's no significant difference between the satisfactory levels of patients during days. So when you say you reject the null hypothesis, that means you fail to accept thank you very much. I hope you wrote it down because it will mean a lot to you. So let's go with replication quickly because we are running out of time. I want to keep this less than an hour so that we don't bore ourselves. So with replication, note, I kind of like changed certain values. This is for shift. This is for experiences. when this data came, what I had for shift was morning, afternoon, night. But I transformed it from morning to 1, from afternoon to 2, from night to 3. Then on junior, I transformed it from 1 for junior, then 2 for senior, because your ANOVA cannot read what they call it, text values, although it is for this software we are using, which is Excel. So now let's go with replication. Oh, let me explain with replication for you. Now, if you notice, there were multiple values for money, multiple values for what? Junior, and the response time. Did you observe? Good. There are multiple values for what do you call it? For each of these. Yes. So at this point now, good. At this point now, you can now look at it and probably say that shift, experience, and response time. You notice that there are replications here. It is repetitive here. So these are factors that you look out for when you're talking about repetition, repetitive, or anything in your ANOVA statistic. So we move from here to data analysis with replication. Yeah. I think I will allow you to build this one. Yeah, this is two-way ANOVA with replication. What's your what do you call it? What is your what is your dependent variable here? Do you know what your dependent variable is? Okay. Now you have two factors here, two independent variables that you're looking at, which are shift and experience, while your response time is your dependent variable. At this point, you would have two null hypotheses to test this completely. The first would be shift have no effect on response time. Whether it is in the morning they have their shift or in the afternoon they have their shift, it has no effect on response time. The last one will be experience has no effect on the response time. So this will just inform your decision making. So let's go data analysis with replication. So now this question, row per sample. You need to know how many rows are in one sample. So let's look from shift. 1, 2, 3, 4, 5, 6. This is one sample. One sample. If you go to the next one, something must inform you of the replication. That means each shift has 6 responses. That's what this information is telling you. Each shift has 6 responses. still in the morning shift, you still have 6 responses for experience. If you notice, there is like a method to it. So it will inform you on how to understand your row per sample. So row per sample here is 6. Okay, look here. Now watch. Usually, before this data comes like this, it must either have been given to you somehow else. So you might be the one that will form this table yourself. Certain times you are the one that will form this table yourself, because I've seen situations like that. But if the value comes like this, you try to look uh, how the kind of pattern that you would look out for here. Look, there is one pattern here in the number of experience and the number of shift. It goes to another pattern. Do you get it? It's confusing. It's confusing to you. Just hold on. Let me just show you this. You will get it. You will get it. When you look at it closely, you get it. So let's go. Let me show you again. So in this first area, that is the first pattern of repetition. You have this amount of data in the first pattern. In this second area, that I said is the second pattern, you have this amount of data in the second pattern. Now watch. In this first pattern, something is unique. You see that the shift and the experience are what is good. The same thing. So something is unique here again. You see that the shift and experience here is what again? Yes, but they are the same. They are the same at that point. Now come back here again. Look at this pattern here. They are the same for these 6 repetitions. That means they were checking response time 6 times when the shift and the experience level are being kept at one place. You get it now? So yes, the patterns are 6. So let's go to data analysis, replication, select your data, row per sample 6, alpha level, and okay. So what will you say about your result here? Now you have sample columns interaction, and within, I would like you to also go and read up about this. I'm not going to explain to you. It's part of what I'll give you as assignment. So check what the samples are, the columns are, and the interactions are, so that it will inform you better. But what will you say about this? Sorry, I forgot to mention we have 3 null hypotheses here. The third one, yes, the third one in this case is called interaction. Okay, let me just give it to you as it is. So what is sample? Let me just give you this one so that you go and decide on yourself. I wanted you to do this stuff. Let me do just this one, then you go and check out sample and the columns yourself. It's an assignment. If you do it, just send it to me. So This is interaction. No, I'm not going to give it to you. Let me leave it so that you go. You do assignment too, so you look at it too. So this is if I give you the final null hypothesis, you will find it out. Okay. The final null hypothesis would be uh, there is no significant difference between yes and experience level. I don't know. I don't know. I don't know. So go and check it out. So thank you, Itinu, for coming to my little TED talk. Uh, maybe some other time we'll do something again. If you have questions, you can ask. You're welcome. You're welcome. Thank you for coming too. For ANOVA, don't disregard that book I sent to you. The Shams outline is one, but you see that design and analysis of experiments by Douglas C. Montgomery. That book is powerful. We use it for advanced analytics in ANOVA, ANCOVA. It's a lot of them. It even went into factorials and block co-founding. So those ones are for higher level analytics. Yes, in ANOVA. Yes, analysis of variance. Yes, I sent to you.